So now let's talk about functions within SQLite. So basically what we're talking about functions within SQLite, is these are ways to manipulate the data, the values that you're getting back from SQLite before it gets to your back-end programming language, right? So with a back-end programming language such as Python, you can do a whole bunch of different things to the values that are coming into Python, right? For like names or for strings, you can make things all uppercase or all lowercase. You can modify them somehow. You can do math, right? You can find the average of values. You can find the total of values. You can do that type of thing. The issue is when you have your back-end programming language doing those types of tasks, it is much more resource intensive than it would be if you have SQLite or the database engine do it itself, right? So these database servers, right, they are optimized to do very specific tasks. So when you're thinking about designing your application, you're thinking about designing the architecture for the application, one of the things you need to be thinking about is where is it most appropriate for a particular task to be done. Should it necessarily be done within Python? You can definitely do it there, but again, especially if your server is under a significant amount of load, maybe it makes more sense to do this kind of manipulation actually within the database server itself, and then only send the results to Python to be able to process from that point on. So here's an example using math functions within SQLite, right? So we have a roster table in there. One of the columns is age, and so I want to get different information about that age column, right? So if I want the sum of all the ages, 10 plus 12 plus 25 plus 26, the whole 9 yards, I can do select sum parentheses age. And so this will add up all the results that come back for age and give me that particular result, comma, the average of ages. If I want to know what the average age is for students on the roster, AVG, and again, age. The max age, who has the top age, right? We do max and then age. Min age, so we can do minimum age from roster. So basically I'm using these functions just as if they're column names themselves, and so sum for age, average for age, max for age, so on. So 166, so if you add all the ages together, it's 166. The average age is 23.71, blah, 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 blah. The max age in roster is 42, and the minimum age in the roster is 12. But here's the thing that I want to show you about SQLite and why you have to be careful with your databases and whether or not you're going to be using strict when you create your table. What happens when you insert into a roster name, age, and sex? So name is a string, text, age should be an integer, and sex is, a text too. But if we did not set the strict data type when we created the table, we can insert different types of values into age, right? So we do values, Timmy, I'm not thinking what I'm doing. So into age, I put Bob, and then I put girl. Then if I do select sum, age, average age, max age, min age from roster, what you'll see is I get 166 here. I get 20.75, so I get those weird numbers. And then if I look at max age, the max age of one of my students is Bob. This is what I talk about. Like, what happens if you 1 and 25 and 26 and whatever, and Bob, and then you try to do a mathematical function off of that? You get some wonky results. And then the minimum age here is 12. So this is why data types and why when you create a table, strict enforcement is important, because if somebody does actually put in a value that they're not supposed to, the results that you get might be rather quirky. Now here's an example using the function for length. So you might use this for passwords or whatever, making sure they're the right length, maybe usernames, making sure they're the right length, something like that. So select name and then length of name from roster. So you can see Bob is 3 letters, Bill is 4 letters, Ben is 3 letters, Sam is 3 letters, Tammy is 5 letters, and Timmy is 5 letters. So using length, it tells us the character length of the value in that particular record. Now in this particular example, what if you do not want to use a method in Python for upper or lower to change the capitalization for the values coming in? You can actually do that directly in SQLite. So we can see here, select all from people. Bob is all lowercase, Paul is uppercase, Tim is lowercase, Timmy is lowercase, Sally is a mix, Mac, so on and so forth, right? So this is a mix of capitalization. Maybe if I want to clean that up when I'm processing Python, right? Maybe when I'm trying to see if two values equal, I want to make sure capitalization is right so we don't get to weird problems. So I can do this, select upper name. So this is the upper function. Everything's going to be uppercase, name from people. Now we can see Bob is uppercase, Paul, Tim, Timmy, Sally, and Mac, and these are all uppercase now. So that's just another example of a function that you can use with SQLite. Now, if you're interested in using these functions, which you should once you start actually building your little products, right? The important thing to understand, as with most stuff in technology, is there's a lot of them. I'm not going to show them all to you today because there's just a lot, right? So there's string functions here, upper, lower, length, substring. You can trim, you can left trim, you can replace actually on SQL. You can do all that kind of stuff. We have numeric functions, right? We can have an absolute value. We can round values that are coming back. We get square roots, we get random numbers, that type of thing here. We have date and time functions, so we can get that type of deal. We can get count, we can get sum, average, max, min, and there's actually even more functions than this. So if you start actually using SQLite and you're thinking this kind of function might be useful, but I haven't shown it to you today, if you go to Google or you go to ChatGPT and basically say, hey, what are all the functions, or hey, this is what I'm trying to do in SQLite, what function will do this for me? You might find out that there is a function that will actually be able to solve your problem. So these functions are yet another example of why whiteboards are going to be so important to you as a programmer. When you start designing the architecture for your application, you need to be thinking about where is the most appropriate place for a specific task to be done. And to think about, again, how different products are optimized in order to do certain things. So since your database server is optimized to do these types of tasks, most of the time it would be much better to run these tasks within SQLite or some other database engine versus pulling all of the values into Python or your other backend language and having them try to process to figure out that information, right? And so this is going to be one of those things you need to consider as you're designing your overall system. Where should different functionality take place? And again, this can be incredibly useful for you, and the resource load doing this in your database system is just going to be so much less than running this with your backend programming language.